what values will be out there that may cause mirage and reflection. These isn't the curvature of the Earth. This was the subject.
Hey, Dan.
There you are.
Dan?
Yeah,
How are you,
hi.
man?
Good.
Hey,
I look
did
forward to
you
kicking
get
your
the,
ass. I look forward to kicking your ass Saturday night. I got the best Flat Earth songs.
Oh, good, dude. Good. Hey, check this out. Yeah, I'm kind of disinvolved in the Flat Earth with it, but yeah, you can bring any song, dude. That's all good. But check this out. Did you see? Did you get any looks or did they get any looks of or partially orthogonal views of the lasers showing them bend up? Was y'all able to show that or record that? Did anybody ever see that when they were out there?
When we have bending up, or what appears like bending up, it's a pretty steep thing, and I don't believe it's anything near refraction. I believe that if you hit the water hard, it'll bounce off the water.
It's literally caused by refraction, Dan.
So the upward stuff that they claim as refraction is a true reflection. You can tell by the angle.
It doesn't even hit the water,
if you're
Dan.
going to evoke refraction all the time, you'll have to attach the math and the conditions. So instant changes in angle are impossible. And let's just get real now, because we've done this for 6-7 years.
Why can't?
I'm sorry for being upset, but this is totally real. Okay.
Well,
listen to me.
I don't want to upset you, Dan.
Please listen, dipshit. I have something to say that's serious. I'm not just whining. Now, vertical gradient refraction is going to take place through atmospheric layers. That doesn't happen down by the surface. The relationship between the surface and the air is the major factor, and then it stabilizes right above that, causing confusion because we have different conditions right above the initial noise on the surface. Please understand that we've been very confused listening to you stupid fuckers tell us about the atmosphere down here at the densest base of it. So we're working not through the mediums of a glass of water. So
that's just the principle, right, Dan?
I know. So stop talking about it, because we understand the principle. We're asking for the math to support the angles. Now let's just go back to Brian, because I think I was clear on everything. Brian, what was your question about upward stuff? I mean, that's if there's a real question. Talking about principles isn't going to help us.
Sorry about that.
It's not going to help.
Yeah, no, I was asking if y'all got any looks, because that's what I was trying to figure out. Because like when they open the door, I mean, you've seen the Sky Free videos and stuff, but I'm trying to yeah, what you said makes sense, you know. So that's definitely a fair argument. But I'm trying to kind of get to the bottom of it and take all the information I can.
Could you explain
take
to me?
Sky Free, and like Sky Free when they open the cold door, but that's extreme, and that is by the surface and everything. But it does show the laser that was visible before they opened the door. It shows it disappear, and it shows objects get lower and stuff happening. And but what you said is interesting, and you know, something I got to chew on. But so you would attribute it to more the possibility of reflecting off the water.
Yeah, definitely, because it bangs. It's like suddenly, boom, it's going straight up. And my own people think it was like a cold front coming through or something. And it's like, no, man. You got to imagine the difference in the angle. You're trying to be level across 10, 12 miles, 15 miles. Just a degree or two will sink you right into the water.
Why do you guys keep calling it bending if you say an angle and an angle is straight?
Because
that would be shut up, Brenda. I'm not done talking.
I can explain it to you.
So what I'm asking is, I know you don't know what I'm asking exactly. What I'm asking is, does it widen like from the source out that way? Are you calling that bending when it just widens in straight lines?
No, he's calling it. He's referring to deflection of the light.
No, he's right though. D-Moc's right. It technically it doesn't bend. It changes angles.
Exactly, 1,000,000%.
But there's so many of them, and they're so small. It looks to the human eye like a bend, and that's what the flat water test that Dan did show that the laser is bending up due to refraction.
Angle?
No, it doesn't. You're just saying that. because you
There's
needed to bend
photographs.
down to make it to the other side. You needed to bend down. So claiming suddenly that it's finding a way to bend up is preposterous because the conditions haven't changed.
Well, they have at night. At night, the conditions are totally different.
Oh, I suppose you've done this and you know what you're talking about.
Are the conditions different at night than during the day?
You're a fool. You've never done this.
They're totally different at night during the day.
But you don't know that. You're just saying stuff.
Yes, I do.
You're in theoretical land again. Go back to your glass of water, stick a pencil in it, and give us a chance to talk about real stuff, please.
I think I want to ask Flat Earth Brian what about his model, which is what I started. We got sidetracked in all this refraction stuff.
Well, he told you it wasn't his model. He said it was somebody else's.
Well, actually, in her behalf, I posted and that also ain't my model, except for it is kind of because I tweaked the extremities a little bit, but it's just an azimuthal, really, an azimuthal centered near the primary, not on it, but near it, and near the equator. I think I still think that the southern hemisphere is a little bigger. You know, I think I'm not calling it a pair, but I still think it's bigger. So and it does make the map look better when you go up a few degrees. And
Brian, you mean the outside edge of a circle versus the inside circle? So the outside circle of a flat thing with a whole bunch of circles, the outside circles are always going to be bigger. It's not a sphere. Why do you keep saying that?
No, I'm saying I'm not saying that to be specific.
Yeah, but you said hemisphere. So what you should say is the flat circles are bigger than the bullseye.
It's same thing as saying light bending. I'm just using the rhetoric, man. If I was technical every single time, but yeah, I don't mind getting technical sometimes, but it's just part of the conversation. They know what I'm talking about.
So but if every word out of our mouth is sphere, I think we're kind of negating any point we've ever started with ever.
Well, the point is sphere. Sphere means just like the influence or your surrounding. It doesn't have to mean
don't exist. Spheres don't exist, and neither do circles in nature. So what would anybody have a reason to talk about them for?
Like because a lot of things are close to being a sphere.
Yeah, like cool story. No sphere. Cool story. Not a 360.
Yeah. So Brian, I'm looking at your post, and these yellow lines and red lines. What do they mean?
Equator, Tropic of Cancer, Tropic of Capricorn. So there's 2 tropics and there's 1 equator, and then once a year it jumps. So it goes over the equator, and then it goes pretty much 3 months in and 3 months back, and then does the jump, and then 3 months. So
the ground there is flat then, right?
Yeah, it was. I'm trying to incorporate perspective to a certain extent with that. But
I don't understand how that could possibly fit.
Well, if you look at a circle out in front of you, and then look at one closer to you, and when you draw the angles, you're going to get different proportions and stuff. So
I don't know what that means, but I just don't understand how this could be tested physically. How would you test this?
Well, you don't have to. I mean, it's what they use for everything, for directional antennas. They used azimuthal. Azimuthal equidistant don't mean just azimuthally equidistant to one place at one time. It means
I know that.
Everything always. Azimuthally equidistant map is every place is the azimuth is equidistant around that spot, period. Always, all the time, or wherever the sun is over, wherever a star is over. Everything is azimuthally equidistant all the time. So that's how they use these. They fire long-range directional antennas like across oceans and shit.
Yes.
Using azimuth.
Yes, they do. Map. Yeah, that is the correct usage of the AZ map. But this doesn't look like an AZ map to me because you have Antarctica as a tiny little island at the bottom and stuff.
That's what it gives you when you see. This is what I'm trying to get across to people. Like, we don't have to be stuck on the Gleason map. We can make different arguments, whether this is reality or not. If you take the AE projection and you put it near the equator because every latitude was based from the equator. So why are we putting the center over the North Pole if we're trying to get a better look at reality? Then why don't we put it where the fucking map was made or where our world was measured?
Yeah.
Not measured. We put it near the equator by the prime meridian, and we get 7 continents that look good, and we get a continent of Antarctica, and we still have a barrier, just a little further out. So
I
it
don't
makes
understand.
so much sense. It explains a lot. So if Cook did try and sail around a ring and went 60,000 miles and shit, and there that plus a continent of Antarctica, it would explain the 9 sunless months of the treacherous Antarctic winter said in the Navy documentary. Because if you went out far enough, you would start getting darkness like that. So they weren't necessarily lying. There's just multiple places.
Right. So when the sun is following that red circle and it's at the bottom that's clipped off, how is it lighting up the Earth, the other continents and countries?
What are you talking about?
You said that the red line is the equator, equivalent to the equator, right? So when the sun, and it's cut off at the bottom, right?
Yeah, let me show you my daylight model real quick.
So that's generally what it follows. So how does it light up the other countries when it's there way at the bottom?
I can show you better than I can tell you. So here, look at this. It's short. This is the daylight. That's night and day mapped out on that model. Right there.
So
when the sun goes around it's like a Pringle. Look, the sun follows like the Analema. So when it's over Capricorn and stuff, it starts going down. Then when it gets past the United States out over the Pacific and stuff, it starts going up. So if you took the Analema and laid it flat, that's kind of what the sun's doing. It's going up and down and around.
So that's
what I'm working on right now.
So where is the sun in this picture that's the thumbnail?
What?
The thumbnail I'm looking at in the chat at the thumbnail for the video you posted, and I'm asking where the sun is and why is there a dark circle in the middle there?
That's darkness. That's the area that's dark. Just watch it. It's only a couple minutes.
He's trying to falsify you. He's asking questions like he wants to know, but he's actually just trying to falsify you in real time.
Well, no, I'm trying to understand it to begin with.
Yeah,
right?
Well, watch it.
And then I would give my criticism. Well, I have you right here. You could just explain it to me. I don't understand this. People, I don't understand this idea that you could just point to videos on YouTube. When you're right here, just explain it to me in your own words.
Okay. If you could see the land, daylight. If you can't, dark.
Okay. Where's the sun?
Look at the video. I'm not going to sit here and explain where the sun's at. The sun's going to be in the middle of the line.
Just point to me on this blue square where the sun is when the shadows are where they are in this thumbnail.
How can I point with my finger? If you look at the video, there's an actual sun in the video.
Is it over? Is it over Australia? There,
Brenda.
Is it over China? China's above Australia there.
At one point, it's where it's supposed to be. Okay, wherever it is.
I don't know where that is.
Listen. Wherever it is, just look at time and date, and then double check it.
Time and date is based on the globe.
Time and date is based on reality.
Yes, it's based on the globe. The calculations are globe calculations.
So what I'm telling you is that if it's midnight over Africa, then the sun's going to be over Africa. If it's noon over Australia in December, the sun's going to be like just north of Australia.
If the Earth was flat, there wouldn't be any time or date.
What?
Yeah, so I just don't understand. I don't understand your model. I'm trying to understand it, and it seems to me I just need a point where the sun is when you have that black circle in the middle over North America, right? And Asia and Australia are in sunlight. Where is the sun on that map?
I don't know what time it is looking at the thumbnail, Brenda.
It's in the sky, Brenda. It's in the sky.
Yeah, I don't know what time I posted on the thumbnail, so I can't even look it up and tell you. I'd have to myself go watch it.
Oh, there's a big circle.
Hold on. I took the time to go pull it up. I took the time to make the video.
Yes.
I took the time to pull it up and post it for you. You can't take 2 minutes to go watch it, Brenda. Come on, man.
So, but you know it better than I do.
It's being hashed out in real time. It's not set in stone. It's not. You could research it yourself. You could start looking into it yourself. There's many different versions of this. Sun could be in the sky. Sun could be in the ground. This is it's
the sun can be in the ground.
It's the general idea that the world's laid out a little bit differently.
The sun could be in the ground. How's that possible?
For you, the globe works fine. So stick to the globe.
How is the sun in the ground, dude?
Alternate version.
Brenda, in your model, Brenda, the sun goes under the earth at night, right?
No.
Okay.
The earth rotates. The sun never goes under the earth.
Yeah, but doesn't the sun orbit the black hole in the center of the galaxy? So I guess the sun moves too, doesn't it, Brenda?
Every 26,000 years. I don't see what that has to do with day and night on the earth, right? And I don't understand how this black circle left of center in Brian's thumbnail, how that happens. It just doesn't make any sense. And I'm asking him to explain it to me.
Could fill a warehouse.
Yeah, that's great. So I don't understand how it could work, you know.
What's your question again?
Well, the thumbnail, I'm looking at the thumbnail. There's a circular black dot over North America, and the other land masses are in light, right? And I don't see how that could work. And I've been asking you just that. I mean, how do you have? How do you have?
Are you making a claim or are you asking a question? Are you telling him he's wrong, or do you want to be educated? Which one is it?
I would like Brian to
You're doing both at the same time. That's why it's aggravating. That's why you are aggravating him.
Yeah, I don't know.
I would like Brian. I would like you to explain to me. I would like you to explain to me how that shadow gets made. What makes the shadow?
What do you mean? What's the shadow?
Ryan, you don't have to answer the question, right? If you want to engage, you can engage. You don't have to.
Yeah, I wish you'd watch it, but I'll tell you this. Okay, the sun light extends from wherever it's at, and wherever the sun's light's not making it to, it's dark. So if you see a circle that's dark, that means the sun's not getting there.
But why? Why?
If you see the edges, listen. If you see the edge, because the light don't go forever, and if you see the sun's light, listen. If you see the sun's light, if it's like on the edges, then that means the sun's real low. Wherever you're seeing it, it's going to be low as shit.
Right. So
don't make the mistake of thinking you're speaking to someone who cares about the truth. Don't make that mistake.
Absolutely. I am absolutely dedicated 100% to the truth. And the truth is that shadows are made by something coming between a light and another surface. Right, Brian?
So if I teach you
something, that was a shadow? Did he say that was a shadow?
That's what it is. Night. It's nighttime.
Nighttime isn't a shadow. What the fuck are you talking about? Nighttime.
That's what that
is the absence of light.
Yeah, because something is in the way. So
not a shadow. What?
That's what a shadow is caused by.
So freaking wrong.
Right, no. Well, then on your globe, where's the shadow at night? So when the sun's going down, where's the shadow? Because it moves from the ground up the building. Why doesn't it shadow the sky? I don't get it. You just said you're looking for the truth, and the darkness is a shadow. So do tell, please.
Yes.
So
okay.
You think that night is a shadow?
Absolutely.
You're dead wrong.
The reason is very simple. Like in the thumbnail, right? it's nighttime in North America. It's daytime in Australia and looks like China. The reason it's nighttime on the globe is because the Earth is in the way.
No, it's because there is no light there.
Yeah, exactly. Because
so not a shadow.
It's literally what a shadow is.
No, it is not.
Why don't you focus on how this alternate model that Brian's showing is superior to the Gleason, the Gleason map?
I was trying to, but and honestly, I'm trying to.
I don't believe that. I don't believe you were trying to. I don't believe that.
What was your name? What was your name before?
It doesn't matter. Focus on the point.
Were you the guy that pretended to be a philosopher?
So if I cast a shadow on the floor, is it nighttime at the floor?
What?
If I cast a shadow on the floor, is the floor nighttime now in front of me?
Yeah, nobody thinks that.
Oh, then what the hell are you talking about? Then a shadow isn't nighttime, is it?
On Earth, the reason that what we call night, right, is caused by
nobody calls night a shadow.
No, the reason that we have nighttime on Earth is because we're in the shadow of the Earth.
No, nobody ever calls nighttime a shadow, Brenda.
That's literally what it is, though.
No, it's not. Where there is no light. It's the absence of light.
But I'm talking about the globe model, and I'm explaining it to you. In your model, then, what causes night if it's not a shadow?
It's the absence of light, Brenda. I just told you.
But that includes the globe model, because the globe model, night is the absence of light caused by the Earth being between you and the light source, which is the sun.
No, that's not a casting shadow.
That's our model.
No, that is not a casting shadow.
That's our model. Our model is that the Earth has a shadowed area, right? Because the Earth comes between you and the sun. That's what causes nighttime. It's the absence of light caused by the Earth is in the way. And that's my model, and I think I can explain my model, right? You can't tell me my model isn't my model. You could dispute it, but it's my model. And I'm trying to understand your model, or actually here, Brian Leakey's model, and I don't understand what is causing the shadow that's left of center in his thumbnail. Seems straightforward to me.
So there's countless
billions. I keep being on mute. Hold on now.
Yeah, hold on. There's countless billions of stars.
Actually,
in your model.
I think the guy who made this is close by,
okay,
man. But real quick, sorry, dude. Sorry. But check this out. I got to go back to what you were saying though. Before I try to explain it, I do ask that you watch it so you could ask a specific question, so I'll know how to answer it. Because you can't just ask me where's the sun at this time and stuff. Because I'm gonna say go look at where the sun's at. And then if you say, hey, the sun's here, how is this? Then I'll know better how to answer it, Brenda. So it's a very short video. But
okay.
I want to say this. You're saying that. Hold on, but before we do, you're saying that nighttime's a shadow. So wouldn't there, if the ground is blocking the light, wouldn't there be a shadow on the clouds and up in the sky? I mean, be honest. You said you're searching for the truth. You're absolutely looking for the truth. You know that the shadows are they're consistent. So
I'm saying yes. I'm saying yes.
There's a shadow on the clouds and in the sky every night.
There is. There is. I'm saying yes. I'm saying yes. There is.
No, there's not.
That would be
every now and then you get a belt of Venus, and you try to explain that away just because you get a phenomenon.
I don't know what the belt of Venus is. Could you explain that?
The only explanation the globe has for that problem I just threw your way, and you're backing it up, saying that nighttime's a shadow. So where's the shadow?
Under certain conditions, you can see the shadow cast by the Earth on the clouds, on the underside of the clouds.
Like to see that.
Yeah, you could. I don't have any of those photos. I don't have any of those actually
but
saved or anything. But yes, it follows logic.
You're saying it's absolute. So it should be
Absolute.
absolutely there every time. As long as we can see the sky, we should see a wave of darkness covering the sky.
Yeah, we do.
Come on.
It's called twilight.
Yeah, why's the shadow stop though?
I don't know what you mean by stop.
We should see a hard line matching the ground.
No, we shouldn't. We shouldn't.
That's what a shadow is. It can be a little faint, but it should represent the ground that's blocking the light, right?
There's no rule. There's no rule that says shadows have to have sharp edges. Right? And the Earth is very big, and we would expect light to diffract around it.
Answer your questions then. So that right there should answer your questions you have about the
What's
model.
that? What's that?
There's no rules about what light should have, what it should do.
There are.
Edges.
Oh, there are. It's refraction and diffraction.
So now there is for my model, but not for yours. That's fair.
What I said was there's no rule that says that all shadows must be hard-edged.
Like I said, they can be fuzzy around the edges, but for the most part, if it's a hard shadow, then it should be apparent.
Sure, but the shadow cast by the Earth is fuzzy. It's very fuzzy because it's round and the light diffracts around the curve of the Earth.
Right? I should be able to put 2 fingers up. If I'm on an airplane, if an airplane flies in front of the sun, then a couple hundred miles away on a cloud, we should see a perfect sized airplane shadow going over the clouds because the light's parallel, right? This light's parallel and it's coherent. So this parallel light should be parallel.
The light from the sun isn't parallel and it isn't coherent light.
That's new to me.
I know. The light from the sun has as off like what is it, half a degree, right? Which is very small. It looks parallel to our eyes.
It's not nowhere near half a degree, Brenda. Not nowhere near half a degree.
It's like literally what it is. Literally what it is.
No, that's the size of the sun. That's the size of the sun, Brenda. If it's 93 million miles away, then it's not half a degree off of parallel. It's like 0.002 or 0.0012.
Literally what it must be. If the sun is half a degree wide, then all rays coming from it must diverge by at least a half a degree.
Okay. So how would we figure that out? You said that we don't know nothing about math earlier. We heard your little snide comment. So how would we do the math to figure that out, Brenda? Let's go over it.
Because you have the light source.
Let's go over how you figure that out.
I was just explaining it to you.
Okay. Fredo.
Yeah, because you have light coming from the right edge of the sun and the left edge of the sun. It travels in straight lines, but the distance between them is half a degree. Therefore, any shadows cast will diverge by half a degree, which isn't a lot to us on Earth, right?
So what's the formula? So you just said right side, left side. So you must know the math because you just dogged us all out, right? You must know the math. So just give me the method or the formula or even the principle.
I just gave you the principle. You have light coming
right side, left side. So
yes,
how are we going to do that?
Because every point on the sun is emitting light.
Just give me the function of math that we'd use.
Every point on the sun is emitting light, and from our vantage point, the furthest distance between those points would be half a degree, and therefore shadows cast by that sun would diverge by half a degree, which is not very easily visible to us on Earth.
What would you call that half a degree in the math? What would it be called?
Divergence. It would diverge by half a degree.
And what would you call the ratio since you have no clue?
It would be
so when you go to
just a divergence.
When you go to make your little sly comments, Brenda, about flat earthers, none of them
you don't
math. They don't.
But you do.
You don't know the math. You don't know the function of how to figure that out. You're saying it's divergent by half a degree, which is ridiculous. Even in your model, is ridiculous, dude.
Why is it ridiculous?
Because the sine of angle 93 million miles away is not no half a degree.
Well, I'm not calculating the sine.
I know you ain't. You have no clue on what to do.
Well, I don't think I should calculate the sine. I don't think I should calculate square roots or sines.
I'll start straight talking with you now. But
well, maybe you could just let me talk a little bit too.
Okay, whoa, guys, this is getting out of hand. Like this is like,
but he's
to sound like in the Peanuts, the people in the background. You guys gotta like either clean it up or we're gonna move on.
Well, I haven't been insulting or ad homing.
No, but it's like you're cutting each other off, and it's becoming like a wah wah wah. Like,
I would like to finish my sentences, please. Right. So it's not so much of a formula; it's just a geometric relation, right?
Yeah, there's a function though to figure that out, though, Brenda.
So the apparent size of the sun from Earth is half a degree, right? So it emits light from all points on the surface, and therefore any shadow cast by a light source like that is going to diverge by half a degree.
Really? What do you think that'd do to the moon? What do you think that'd do to the moon's shadow if it was how much do you think it'd be divergent on the moon?
I don't know what you mean. I don't know what you mean.
You think that we see the sun's light diverging by half a degree, and ain't that what your what refraction makes it move by? Is like half a degree or something? Sure, you're not getting things confused.
No, I'm pretty sure I'm accurate on this.
Hold on, before you continue. So you're telling me by your paradigm that supposedly the sun is being shadowed, right?
I'm saying that the Earth. No, I didn't say the sun. I said that. Well, the Earth comes between you and the sun, and that's what explains nighttime.
So that's what nighttime is. So are you saying space is a shadow?
No.
Wait, but there's no light. It's dark out there.
No, it isn't.
What? Have you seen videos of
space? If you go out in space,
show me a video of space where everything is a light.
If you go out in space, you will be lit.
You haven't been out there, so you can't tell me if you go out in space.
I would like to finish my sentences, please. Can I finish my sentences?
Yeah, if you go quick, let me say something.
If you go up,
it's 0.004 degrees, Brenda. That's the divergence.
So I haven't been able to finish my sentence yet. If you go out into space, you will be lit by the sun. That's why we can see satellites at night, because they are above the shadow of the Earth and being lit by the sun.
Yeah, but the Earth's diameter is 8,000 miles wide, just using the entire Earth. Okay, with the sun 93 million miles away, I posted the math. It's 0.004 degrees divergence. That's assuming that it's covering the span of the entire width of your ball Earth. So when you say it's divergent half a degree, no, that's the size of it. That's the angular size of it in your model. So get your shit straight. Quit dogging out people.
Don't know what you're talking about.
And everybody, like, some people do math, okay, that are globers, and some people fix cars. Some people do other shit that are flat earthers, okay? So if somebody doesn't like to do math, that's not their trade and shit. Doesn't mean they couldn't learn it, Brenda. Okay, if they wanted to take the time to learn it, they're not monkeys. Okay, you haven't took the time to learn it. So quit dogging other people who had to try and grandstand and sound like you're smarter than everybody else. Be condescending.
Well,
please.
Maybe just reduce your ego a little bit and don't be offended if somebody corrects you.
That's what I'm trying to tell you. If you correct me, then that's fine.
Yeah, I did. Right?
I'm trying to
explain to you. No, I explained to you why the rays of light coming from the sun diverge by half a degree.
You still saying that they diverge half a degree, even after I explained it to you and posted the math.
Yeah, that math doesn't have anything to do with what we're talking about.
Okay. How can it diverge by half a degree? So let me ask you this. Okay, let me ask you this.
Don't switch. Don't switch. Don't switch.
If I put a pole in the ground and I'm checking for time like a sundial or something, you're telling me that the sun's rays that are putting the shadow on the ground are going to diverge half a degree, Brenda?
I think
that's going to be 30 minutes on the clock, Brenda.
I think there is a misunderstanding here. So the angular size of the sun is half a degree.
That's what I try to tell her. She's saying I got to go for doing it.
That means if you have an object that is casting a shadow, that shadow is decreasing in size by half a degree as it gets further away from the element that casts the shadow due to the size, due to the sun not being a dot light source, not a point light source. But
exactly.
I don't think that if you have two poles, the shadows between these two poles are actually getting closer together or far apart half a degree as they gain distance to the poles
but here's
itself.
The point. Here's the thing: is I referenced putting my an airplane 200 miles away, and I said in the clouds. This is where it all started from. I said that a cloud 200 miles away should have a damn near perfect shadow of an airplane on it above the surface because it's only divergent by 0.004 degrees roughly. That's not the exact math. That's pretty damn close though. And she's saying no, that shadow would diverge half a degree. Okay, she's probably going to deny that now. That's where it all started from. So if she could admit and humble herself one time and admit, okay, yeah, that's I think you're right, Brian. It is the sun's rays won't diverge by half a degree.
The sharpness, the half shadow.
Pictures, Brenda. Can you tell me where's the shadow and what's casting the shadows on the dark sides of the sky?
But you always have a core shadow, and then you have this. I don't know what
the term is. Brenda,
number.
Brenda, where's the shadow coming from? The sun being out and those pictures I just posted.
He's not here anymore.
Did he leave?
It describes. They're talking about the feathered edge of the shadow. The feathered edges of the shadow.
Feather edges
will be half a degree.
No,
if you measure over distance from where it's cast.
That night is a shadow. So I'm asking, in those pictures supposedly of the ISS right there that I posted, was casting the dark of that shadow that's all over the quote unquote space.
You're the Brenda Destroyer. Nice move, bro. It was going around in circles. If that's what it took, good on you. Obviously, Brenda could have just gotten a phone call. I'm just joking, but
yeah.
If the air is clear on a dark night and there could be a spotlight going over your head, but if there's nothing to reflect it down your way, the light's still there. It seems like that's what you're trying to compare.
He's saying that's a shadow. Night is a shadow. That's what he said. That nighttime is a shadow.
Not seeing the sun as a shadow. And it's nighttime for you because you're in the shadow.
He said if there's dark, is a shadow. That's what he said. Dark is a shadow.
And double down. Yep.
A black car in sunlight is not a shadow. It's dark. A dark car.
Don't take it up with Brenda.
Not a shadow.
Take it up with Brenda. Take it up with Brenda.
Nighttime is
that's got to be one of the weirdest arguments I've ever heard. Like,
okay, but now you're mixing up. You can say nighttime is a shadow, which is correct, but then saying dark is a shadow, which is not correct.
Well, that's what I said.
Can light make a shadow on light?
It's time to kick it into high gear. Get him.
Yeah. Light, a greater light, can make a lesser light appear to be a shadow. That's weird. But I didn't say nighttime was a shadow. But I will say the eclipse can be an actual object that's not as bright as the other object that's about 1 million times brighter. And you're going to look at a black object that's really lit up in front of another lit up object.
Yeah,
So
if you
depending
light with
on,
a
yeah, lots of cool stuff can happen. Sorry, go ahead.
if you light with a flashlight to a candle, you will see the shadow of the flame on the wall. Because
Do you know what a shadow is?
It's obstructing the light from the flashlight going to the wall, so it's hindering it.
Do you think a shadow exists, News?
No, the shadow is just the absence of light.
Right. So what's the difference between dark and a shadow if both of them are the absence of light?
What is the difference between rainwater and seawater if both is water?
That's
I would.
completely
The
that's
shadow's not the
non-analogous and
absence of
irrelevant.
light.
Yeah, I'm gonna say that's completely wrong. I don't think a shadow is an absence of light. It's an obstruction of light.
Yeah,
Yeah.
because it is light.
Yeah, that's
It's
better.
the other light being outshined, like I just exclaimed with the eclipse, man. It's the same exact thing. If you stand in the way, the part of light that's
All
coming
right, I'll
around
let
you that
you keep on.
widens, yeah. Well, you don't like reality?
But I mean, still, a shadow can only exist. Like it's a theoretical concept to describe that you have some light missing due to obstruction of light or due to kind of obstruction of light or hindering light to pass. This is called a shadow.
I don't know if you were
And
outside when you
if
said
look,
that, but I was looking at a black truck when you said that, and guess what? Only the parts that are in shadow are black, and the rest are just reflecting light.
yeah, but there is, for example, like this what is it, Black 3 or so, this super black paint that is made of a lot of like coal or carbon that is actually like sucking in every light that are like not reflecting any light, kind of.
So it's obstructing all the light. So it's casting a shadow.
Not entirely true.
It's casting a shadow on the object, right? Because it's obstructing all the light.
We gotta go one at a time. Everybody's over talking. Hey! Everybody's over talking. Let's go one at a time.
There is paint that absorbs light, about 80 to 90% of light.
Yeah, and you could call it kind of dark, but it's not a shadow. And the same, for example, if you look in the night sky, you can clearly see darkness, but this darkness is not caused by a shadow, it's just caused by the absence of reflection. So why you see a blue sky in the day, it's because the particles in our air are reflecting the light, which is referred to as diffraction. And this diffraction then colors, because it's reflecting blue light, it's coloring our sky blue. And in the night, this does not happen. Or on the moon, it does not happen. Therefore, it looks dark because there's nothing lighting it up, but that's not a shadow.
It's called Mosul Black. Go ahead, Sid.
Okay, let me simplify this, right? Because we're going on, and this is very simple, right? I'll ask one question. Can you have a shadow without some sort of light in an object?
Who you're asking? Are you asking me?
In general, yeah, anybody.
Yeah, I don't think you can have a shadow without no light.
Well, I think you
that
can.
answers it right there.
I think you can. I think a shadow and
only
darkness.
have a shadow without light.
Okay, I wasn't talking. Go ahead.
Oh my god! I just think that you can't have a shadow with light technically.
Yeah, are you sure? But let Elbow. Who was it that went?
It was Dice Low.
I mean, if you
gave up.
if you close your mouth,
you're not Dice Low, bro. Like we all jumped in here, right? We're all anxious, but
yeah, I think Dice Low left.
Dice Low.
Dice Low left.
Oh, that's not good. Okay, then it was the girl, the lady. Oh, I'm sorry, I don't know your name.
Pumpkin, madam.
That's all right. I already said my piece.
You said something about you can't have a shadow with light. You said.
Yeah, technically, I mean, really, here we're talking about shadow can't exist with light, right? Because it only exists where the light doesn't touch.
Incorrect. It has shadow only exists when there's something obstructing a light.
Well, technically, that's only from the perspective of someone who can only see with light. So, I mean, if you were maybe living in a shadow realm, you would only see shadow.
Are you going to theoretical spots? Come on now. We're talking
Well,
about
I mean, like,
we're talking about
think that
reality, not theoretical.
that's what you can observe with your eyes, right? So, I mean, technically, you'd be in shadow without a light. You'd be in darkness without a light. If you were in a world where there's only darkness and then you introduced a light, you'd see it the other way, rather than a light where then we just get relief from it through a shadow, right?
If you're blind, you can't see light. Then,
but I think in general,
there's no light. There's no light if you're blind.
Yeah, we are talking about visible light
man.
here, right?
Come on.
I mean, let's be clear, right?
I'm just saying the technical nature of it versus what, like, our actual perspective of it is. Like, you have to differentiate the two.
If there's something in between you and the light, you're gonna cast a shadow.
But what if there's no light?
What?
What if there's no light?
Then there's no casting of a shadow.
There's nothing to cast a shadow, but it's still dark, isn't it?
Yeah, but that's the difference between darkness and shadow. So shadow is the area of darkness caused by light being blocked.
Stop.
Wait a second.
Like, did you just hear what she said? Did you just not just hear what she said? If there's no light,
I heard what she said.
Yeah, but then
I heard what she said. I just wanted to react on that.
Okay, I don't care what you want to. Why does she want to say if there's no light? We're talking about casting of a shadow has to do with an obstruction of the light between the light to be cast a shadow.
Well,
otherwise there wouldn't be a shadow.
To me, it's a question of
let Pumpkin answer. Let Pumpkin answer.
Thank you. For me, it's a question of do light and shadow exist independently of one another? And I think the answer is yes.
So you think a shadow can be cast without a light?
I mean, not cast, it just exists.
Where does it exist?
Huh?
Where does it exist?
Anywhere there's no light.
But we are just mixing up words. What does that?
We're not mixing up any words.
Light is required for a shadow.
You cannot just say shadow and darkness.
For a shadow, you need a light and an object. No, Pumpkin?
I mean, in the traditional sense of what they call a shadow.
Traditional?
Yeah, I'm just saying, if you wanted to, I mean, all this shadow and darkness and stuff, like, I don't know, like, I think God creates our shadows.
I'm like, this is just ridiculous conversation, dude. Like, are you seriously taking this? Well, I don't know, because
Elbow, I feel your pain, bro. Let her finish.
This light and darkness being like connected like this, I know it's like saying like there's no such thing as cold, and cold is just a lack of heat. Saying, oh well, darkness is just a lack of light. I just don't think that
is exactly what it is.
That's exactly what it is.
Well, then how is the moon? How is the moon projecting cold light then? If there's no such thing as cold,
it doesn't. But the thing is, a shadow does not necessarily need to be dark. So a shadow can be still bright, but darker than the surrounding. So, for example, in daylight, if you cast a shadow, it's not pitch black. So there is two different words for two different things. They have something in common, but darkness and shadows is not a synonym to each other.
Hold on. Am I not talking to the people I thought I was talking to? Because I know that there were experiments in this server showing that moonlight is cold. So is this not the same group of people anymore who believes that?
Does light has to
that did happen here. She's right.
This group's pretty mushy these days. It won't cop to anything.
Hey, hold your
don't forget,
tongue there,
people are individuals.
But that did happen. There was a whole bunch of people. It was like a moonlight-a-thon. Yeah.
Yeah, I tried that same quote unquote observation with or measurement with on a day that there is no moon.
The thing is with the moonlight
when there's no moon,
right? On what is it called? New moon. quote unquote.
You can, if you make the experiment right, you can verify that the moonlight doesn't make any difference. The problem is just if you cover something, or you have an umbrella or so causing that umbrella is actually reflecting the heat back that is coming from the surface, so the heat radiation from the surface, and it's kind of stopping the evaporation of moisture, and it's reflecting heat. So that's why the stuff below the umbrella is warmer than outside of the umbrella. But if you do that vertically, for example, or with, I don't know, you can eliminate these effects, and then you will see that the difference between moon shadow and the moonlight will not make any difference.
That sounds great. Show it.
It sounds like we need to
my
do
question
the
is,
experiment
hold on. So yeah, I mean, if y'all did it with the moon, did y'all do this same quote unquote experiment without the moon on a new moon? No answer. Anybody? I'm asking anybody that was supposed to be here.
Did you step out with a thermometer and umbrella when there is no moon at night and then do the same test?
Yeah, the
They were
variation
doing
is
it with
just too high.
moonlight versus moon shadow. So I don't know how that would affect it. How could you do it with a new moon? Yeah, moon shadow versus moonlight. So when there's shadow from the moonlight, right? So you can check in the shadow of the moonlight, and you can check in the light of the moonlight.
Yeah, but it's still, you need to do this without the moon being out.
You can't do it without the moon being out because there's no moonlight.
Why wouldn't you? So you need light to be able to cast a shadow. Then now.
Now the question is, what you're measuring?
Well, hold on.
Is
She just answered her own question. Do you need light to cast a shadow?
The shadow exists regardless, right?
You could do it. So hold on. So
at the new moon, you're gonna have
you just said the shadow
just shadow.
Okay, so hold on. That means you could do it without the moonlight then, because the shadow exists regardless. So
no, because it's measuring moonlight. So how are you going to do it without moonlight?
Hold on, but you just said the shadow exists regardless.
Yes, you can measure the shadow at all times. That's the nighttime.
Okay. Are you double speaking? Essie, is she double speaking?
Well, look, I mean, you can't have it both ways. But look, she's not going to concede, bro. But look, Elbow, I hear what you're saying, bro.
No, I asked you, is she double speaking?
Or yeah, it would appear so. It would appear so if I have to be honest.
How am I double speaking? Listen,
because
the shadow of the night is there at all times. Okay, when you have a light source, then it's going to penetrate through that shadow and be moonlight, right? So then you have the moon shadow and the moonlight. So you have all the shadow all the time. Whenever there's moonlight, then you can see the difference between moon shadow and moonlight.
Yeah, but Elbow's trying to show you the difference between the absence of light, darkness, and a shadow, which requires light and an object to cast a shadow.
Correct.
I know the traditional understanding, but I'm saying if you were to take a step back and look at them as separate objects.
Look at what
do you mean separate objects?
So shadow being something that is obscured, right? That's obscuring. Light being something that's revealing.
Yeah, right. Yeah.
No, I thought you were separating dark and the shadow, not light and the shadow.
Yeah, that's what I thought, to be honest. Yeah.
Yeah.
No,
because they are two distinct things. There's no questioning that, right? I mean, can you question that?
You can question anything.
Well, by the whole shadow thing, they imply that darkness is attached to light, and I disagree with that.
I think that's not.
Moving on to something a little more productive. Did anyone go out with the umbrella when the moon was not out at night, and then do the same test with maybe a glass of water and a laser thermometer, and then go out with the same umbrella when the moon's full, and then do a test with the laser thermometer, glass of water in the shade of the umbrella, and then not in the shade of the umbrella? Did anyone compare those two different nights with the moonlight and then not moonlight in the shade of the umbrella?
You're not controlling for enough variables to say you're ever testing moonlight.
No, you can do that. In my opinion, he's absolutely right. So if the moonlight is causing a temperature difference, let's say we have full moon, and you put an umbrella or cardboard or something in there, and you can measure a temperature difference between the center of the shadow of the moon and then the grass or the street on the side, and that street on the side is cooler than the center of the shadow, and you do the same experiment on a new moon with the same cardboard and the same construction, and the part below the cardboard and the temperature difference to outside of the cardboard, even though there is no moon making any difference, you will or you should measure the same differences.
You're not measuring the moonlight. You're measuring the air and the temperature.
You're
and the
measuring the difference between below the umbrella and outside of the umbrella.
That's not the moon.
Independently of shadow or not.
You're not measuring moonlight.
Measure a difference or not.
No, the point is exactly you are canceling out if the moonlight causes the difference or if the moonlight doesn't cause it. When you once measure with new moon and once measure the same 2 points on a full moon, and you would have the same temperature differences or a similar temperature difference.
You'd have to be able to demonstrate everything you said. Brother, hold on. You'd have to be able to demonstrate everything you said on both accounts. One without a medium, only moonlight. One with a medium and moonlight. See the differential between those two. And then see the differential without a moon. And then see with the moon. So, like, I don't think you know what you're talking about.
What has the medium to do with that?
Everything. Every single thing.
So if the claim is the moonlight is causing the temperature, if the claim is the moonlight is causing the temperature difference, and you can measure the same temperature difference on a new moon, then you would definitely have proven that not the moonlight causes that.
You're measuring the temperature of the air around your thermometer, brother. Calm down.
Yeah, but no one claimed that it was caused due to the medium. So what the fuck has the medium to do with that?
No, when are you testing only moonlight and not a medium? When did you get rid of the medium?
D-Mock, no one said anything about getting rid of a medium. No one said anything about
I certainly did. That's how you manipulate the variable. That's how you figure out whether you're testing medium dog shit or moonlight. Brother, last time I checked.
The medium is always
we're trying to measure whether or not the medium, the air, is increasing or decreasing in temperature.
Are you measuring what the moonlight's doing? Are you measuring what the moonlight's doing or what moonlight does in medium?
Well, we're trying to measure what the moonlight does to air.
What it does to air?
Well,
how do you know it's the moonlight doing that, not your hopes? How do you know it's not your hopes and dreams doing that?
Yeah, we could then do the same thing and going away.
No, I'm kind of asking you how you can prove your point without making stuff up. Why is it so hard for you to understand?
So, Democh, why is it so hard to understand that if you claim a cause and then you remove the cause and have the same effect, that it's not the cause? No one was talking about the medium. The claim was about the light. You don't have to.
Who has been close to the moon and tested moonlight to see if the moon?
Umbrella. You don't have to cancel out the medium.
You don't even know what the moon is.
That
moonlight
doesn't matter.
Or what? What's moonlight? Tell me that first of all.
It doesn't matter.
It doesn't matter what it is that we're testing. Dude, come on now. Stop with this shit.
It doesn't matter in which country you do. It was not about countries. It was not about medium. It was not about moon or what the moon is or if it's physical or if we are a ball earth or a flat earth. That all doesn't matter at all about this specific claim. That's how you do experiments.
The moon doesn't matter about talking about the moon.
If the claim is that light causes a temperature difference and you remove the light from the whole experiment, then you have changed your independent variable.
What kind of light?
The fucking moonlight.
What is that?
I don't care.
You don't care, so stop acting like you're going to figure anything out. If you don't even know what the moonlight is, the very thing you're talking about, stop trying.
You don't have to know what it is to
Holy
figure
fuck.
out if it causes something.
Yeah, okay, Narnia. Right. You don't have to know anything to know anything. I got you, brother. You're not making any sense for yourself. I hope you know that. None of you guys can help each other on this ignorance. I hope you know
I
that because
can
ain't none of you been to the moon. None of you know what a moonlight is or whether the moon's actually putting off the light because none of you got no moon in your back pocket and you didn't make one. So stop
Yeah,
acting like
I
you
can
guys
hit
know
your
what
thumb
you're
with a
talking
hammer,
about.
and you can tell me if it hurts or not without
I don't
knowing
have to
what the
tell you
hammer is made of.
nothing, makeup guy. I don't have to make up stuff. That's what I'm not going to do. But I'm going to try to keep other people from doing the weird shit.
I got an idea. Hey, D-Mock, how would you suggest that we test whether or not the moonlight makes things change temperature?
I suggest you guys stop making weird shit up.
Yeah.
So in other words,
answer is also a good
fucking
answer.
derpy,
Don't
derp,
make
derp,
shit
derp
up.
is your answer.
No, there is no other words. Don't make shit up is my
Flat
word.
earthers are the ones that made up that moonlight is cold, so.
No, I didn't make that up. I'm a flat earther. Nice to meet you. My
You
name's
support it
DeMock. I
though,
could
so.
care less
Guys,
about the
remember,
fucking
no
moon.
matter how stupid any flat earther gets, no flat earther will be more stupid than a glober.
That's not even nothing to do with any of it. Here's the thing. Nobody has to make dog shit claims. I'm not selling you guys anything because you're not buying anything. I'm not selling you anything to be bought from me. I'm not selling you a fucking sad story of cartoons. I'm not making any fake ass predictions like Nostradamus. I'm not doing a bunch of goofy shit. I'm going to do trial and error, attribute, action, and reaction. If I go out today and the action is this, good fucking tidy-o. If I go out tomorrow and the action is this, tidy-o. That's the only thing I can work with. I can't work with ifs and buts and candies and fucking nuts.
All right,
Yeah,
but
if you're not interested in all these,
I'm still
if you're not interested in the
hold
claims
on.
and the cause, why are you contributing
Yeah,
here?
but this was a subtopic to the topic we were talking about. Can there be a shadow without a light?
Oh, you're done with that. Are we
No,
done with
because
that?
no, because this was the subtopic. Somehow somebody said that the shadow's always there. So I'm just trying to figure out how is that possible.
It's not. I went over it with this long time ago, all the time, lots of times. You have to have light to have a shadow. It doesn't matter how much you help till you're blue in the
I think
face.
this boils down to a game of semantics. Nothing more, nothing less.
No, because then you're saying because they're saying that the darkness is a shadow.
Yeah, I think no one except of I don't know what the name of the woman was said that.
Well, I mean, he's not alone because Brenda was another one. Brenda
Did
was
he?
another
I
one
don't know.
saying,
She?
yeah,
I don't know.
Brenda said.
That's Brenda.
Brenda said, and then somebody else was backing him up, saying that
Okay,
darkness is a shadow.
Then the people who are still here can just agree shadow is a theoretical concept, but in our language, it's the absence of, or it's the area where something is. What was the definition? Wait a second.
Well, it was where the
So
light
an
was
area
being
of darkness. Wait a second.
Obstructed.
I think that's a pretty good definition. An area of darkness caused by light being blocked by something. Okay?
Not necessarily total darkness, because remember, even a flame can have a shadow.
It didn't say total darkness. It's just darkness or darker area. We could also say that. A shadow does not need to be absolute. But for example, if you close your mouth, you wouldn't call the darkness inside of your mouth being a shadow. It's just dark. A shadow has corners. In the ground of a dark cave, you wouldn't call that a shadow. That's just darkness. Shadows has borders, right? No?
No.
Shadow has borders, you said?
Yeah, I mean, typically you wouldn't claim just if you switch off the light in a room without windows and without doors, you wouldn't call that a shadow. But if you're standing in the sunlight and you see something that has a clear border, that is a shadow. It's an area. Areas need a start and an end.
I can't believe we're still talking about shadows. Like I feel like going and banging my head on the wall there.
I thought the lady was still here because she said something and they that I didn't vibe with, but somebody else started talking and then I couldn't get back to the point that she said.
I think we all agree what a shadow is. I think we are mostly aligned here. I think we don't have to discuss about this semantic anymore. I thought she was
still here. I thought she was still here. I thought she was still here, but she's not. So we can move on.
So then we could maybe just.
That was completely weird that she was saying that shadow still exists even if it was dark. I'm like, where, bro? Where is the shadow? And then when we brought up the moonlight, and since she brought up the moonlight, I said, well, okay, well, then do it without the moonlight. And she's like, no, well, there's no shadow. Okay, then. And she still kind of wouldn't concede. And then she said something else. Not sure what it was, but okay. Anyways, we can move on.
Back to the 0.5 degrees claim. So this kind of divergence or convergence or however, I think it's mostly about the core shadow being smaller, or this like, I don't know what the English term is, the half shadow. So the area that is partially lit, so the gradient between the core shadow and the fully lit up part, that is getting bigger. That area is getting bigger by 0.5 degrees. And that causes, for example, on the globe model, the distance between the moon and the Earth's surface, having the core on an eclipse, the how do you call what's the word for the core of the eclipse? The dark area.
The umbra.
Umbra.
Was umbra? Wasn't it something like the full path or something like this? Or the totality. So the path of totality or the area of totality. This is kind of by distance to the moon, 0.5 degrees getting smaller compared to the surface of the moon. And then you have the area where you don't have totality but a partial obstruction. This is getting.
You're talking about two different things. You're talking about the path before. That's the path.
No. The path is just this thing over time. I mean in the moment
the path
of time.
Of totality.
Yeah, but in the moment of time, you have not a path, you have kind of a circle of totality. And then you have a circle area of partial obstruction, like a gradient between
the umbra, penumbra.
Okay.
And there's even another one, which.
Yeah, and then you have the area where the people don't give a shit because they don't have an eclipse, right? So
what are you talking about? Are we measuring the shadows of the? Are we measuring the heat of the shadow? That's
no, the size. The size. I mean, you measure the width and the length of the shadow.
Okay, so
of the moon, for example.
Okay, before you continue, man, because now I'm lost in the conversation because I thought we were talking about measuring the light and the shadow, and if it's the temperature change of the shadow. Are we onto something else other than just measuring because this was the conversation.
Now I was going back to this 0.5 degrees that she brought up before we talked about the moon and the shadow stuff. So the 0.5 degrees is the rate where the core shadow is getting smaller compared to the object that is casting it, because of the angular size of the sun. So if you have an object that is 1 meter in diameter and you hold it up in, I don't know, 10 meters height at the equator at midnight, at noon, so it's casting a shadow totally vertical down, you will see that like the object is 10 meters height, 1 meters in size, and then you will see that at the bottom, you will have a core shadow that is this 0.5 degrees. I would have to calculate it, smaller than the object, but you would also have a half shadow, like this gradient part, that is 0.5 degrees bigger than the object itself due to the angular size of 0.5 degrees of the sun. And that angular size is everywhere on Earth, every time. The only thing where it differs is during sunrise and sunset. It's getting a little bit squeezed top to bottom. So it gets a little bit smaller than 0.5 degrees. And maybe it's not accurately 0.5, but it's the same everywhere. So all agree? Okay.
I didn't agree on anything. I wasn't paying attention. I was doing something else. So don't count me in on that one.
Yeah, I was just kidding. I know that you wouldn't agree at all with me.
So you can't have it. You can't have a shadow without a light and an object. Visible shadow, right? It's that simple.